Alright guys, today's goal, the learner will understand how to graph and work with polar coordinates. We're going to be going over the polar coordinate system, coordinate conversion, equation conversion, and finding distance using polar coordinates. Use of polar coordinates sometimes simplifies complicated rectangular equations, and they are useful in calculus. Okay, so let's take a look at the first example here. Okay, so the polar coordinate system. The point is r comma theta, so the radius and the angle. Here's the origin, polar axis. Okay? Plot the points with the given polar coordinates. Okay, so first step, draw the polar axis. It's 2 comma pi over 3 because this is your angle. Okay. Now 3 pi over 4 negative 1. So again, draw the polar axis. If I move 3 pi over 4, I'm going to be over here. But see how it says negative 1? That means you got to go this way. So that's negative 1 comma 3 pi over 4. Okay. Normally the positive would have it going up, but since it's the negative here, you have it going down. Now, so I look at this one. Three comma negative 45 degrees. See, you move the angle and go in the direction of the angle. If it was negative, you'd have to go that negative direction, the opposite direction that you stopped at. See how you're moving this way? We got to start by joining it. Here, we were moving this way, but instead of going the positive towards it, you went the negative, okay? So there's just drawing the generals. So let's take a look at the next piece. Finding all polar coordinates of a point. Let the point P have polar coordinates r, theta. Any other polar coordinates of a P must be in the form of r, theta plus 2 pi n, or negative r, theta plus the quantity 2n plus 1 comma pi, where n is any integer. That's very particular. In particular, the pole has polar coordinates 0 theta, where theta is any angle. Alright, so let's just start. P equals 1. So you have r comma theta. That's what we have right here. There's r, there's theta. So if we just look at this first one, r theta plus 2 pi n. So 1 comma negative pi over 4 plus 2 pi n. There's one. Now follow the other. Negative r theta plus 2n plus 1 comma times pi. So you also have negative 1 negative pi over 4 plus 2n plus 2n plus 1 pi. N is any integer. Okay, what you're just doing is going around the circle again. That's why. Think about the unit circle. 2 pi to go all the way around. That is why. So here, I'll do an example of the first part there. See, if I move negative pi over 4, I'm right here. If I add 2 pi, I'm right back here. If I subtract 2 pi, I'm right back there. So it doesn't matter for n as any integer, okay? Let's look at the next. Let P have polar coordinates r theta and rectangular coordinates x comma y. Then x is equal to r cosine theta, y is equal to r sine theta, x squared plus y squared equals r squared, and tangent is y divided by x. These are things we need to know. Okay? So let's see how we would apply these now. Find the rectangular coordinates with the polar coordinates 2 comma 7 pi over 6. Okay? Well, we know x equals r cosine theta. Well, we know that r is 2 and theta is 7 pi over 6 because this is r comma theta. So you get x equals 2 times the cosine of 7 pi over 6. Well, what's the cosine of 7 pi over 6? Negative square root 3 over 2. So you get negative square root 3. There's x. So we get y equals 2 sine 7 pi over 6. 2 times negative 1/2, because sine of 7 pi over 6, negative 1/2, negative 1. So my rectangular coordinates, negative square root 3, comma, negative 1. Alright, let's try the next one. Okay, so it says, find two polar coordinate pairs for the point with the rectangular coordinates, 1, negative 1. Okay, so if we think about this. We have this point, that's 1, negative 1. So if we found the radius, you would say r squared equals 1 squared plus negative 1 squared. So r squared equals 2. So r equals plus or minus the square root of 2. So now we have r, and so we can use the x equals r cosine theta. So you say 1 equals square root of 2 cosine theta. Cosine theta equals square root of 2 over 2. So then theta equals the inverse cosine square root of 2 over 2. So you have pi over 4. Okay? So now we know theta and we know r. So we have 1 point. We have square root 2 comma pi over 4. Or we could use negative square root 2. And that would be 3 pi over 4. Because if we did this, if we said negative square root 2 sine theta equals 1, or sorry, negative 1, so you get sine of theta equals negative square root 2 over 2, which would be, so you'd get negative pi over 4, but we go to 0. So there you go, you could have negative square root 2 comma negative pi over 4. Okay? Or you could have negative square root 2 comma 3 pi over 4. So there's a lot of different ones you can get. Let's take a look at another. It says convert r equals 2 secant theta to rectangular form. Well, I know this. R equals 2 over cosine of theta. And if I multiply both sides by the cosine of theta, you get r cosine theta equals 2. Well, we know this. X equals r cosine theta. So x equals 2. So there's another example. Let's look at the next. All right, it says convert that to polar form. Okay, so when it says convert that to polar form, we know it's a circle. We got to figure out the r here. So we need to convert to polar form, so we need to get r equals something. So square both things, so you get x squared minus 4x plus 4 plus y squared minus 6y plus 9 equals 13. Well, if I subtract the 4 and the 9, that's 13. So I get x squared minus 4x plus y squared minus 6y equals 0. Now I know if I change this, I have x squared plus y squared minus 4x minus 6y equals 0. Well, I know x squared plus y squared equals r squared. And I know x is r cosine theta. And y is r sine theta. Well, if I factor out an r, I get r times r minus 4 cosine theta. Cosine squared. Cosine theta minus 6 sine theta equals 0. So I set each factor equal to 0. R equals 0. R minus 4 cosine theta minus 6 sine theta equals 0. That doesn't do me any good. Add those over, you get r equals 4 cosine theta plus 6 sine theta. And there we go. We have r and theta. All right. See you guys tomorrow.